Good morning, everyone. My name is S. Vigneshwari, Assistant Professor from SNS College of Technology in the Department of Electronics and Communication Engineering. So, today I am going to handle the topic on Diac from the subject Basic Electrical and Electronic Circuits. So, kindly watch my previous videos on special semiconductor devices on UJT and varactor diode. So let me give a quick overview of what we are going to discuss in today's session. So first we need why we need a diac, right? Then we'll move on its definition, followed by its construction, working principle, and then with the IV characteristics, ending with the applications and advantages. So let us begin. So why do we need a diac, right? So what is Diac mainly? So before understanding the device, let us first see why it is needed. So in AC circuits, the light dimmers or say for example a fan regulator even, we need a smooth and controlled power delivery. So if switching is not properly done, it causes a flickering or a noise that may you have noticed in your day-to-day life also, in your home too. So we require a device that can provide a sharp and stable switching. Here Diac comes the play here. So Diac helps in achieving this by ensuring proper triggering. Coming to the definition of Diac, it is a two-terminal semiconductor device so that conducts current only after a certain voltage level is been reached. So which is called the breakover voltage. It is a bidirectional device and it will conduct in both the direction, right? And this will conduct in both the direction and it is majorly used for triggering the TRIAC. So TRIAC will be using for also AC power supply of smoother delivery operation. So Diac in general, this is an acronym for diode for alternating current. Next we'll look into the construction of Diac. So how a Diac is being constructed? So a Diac has only two terminals and does not have a gate terminal like some other devices as we see for the SCR purpose. So it is made using semiconductor layers arranged in a symmetrical structure. And the symmetry here is very important because this allows the device to operate equally in both the direction. So due to this, Diac provides a consistent performance during positive and negative cycles of an AC signal. Principle of Diac. So how is a Diac is applicable for this smooth triggering purpose, right? So when a small voltage is applied across the device, it remains in the off and does not conduct. Only a very small leakage current flows. As the applied voltage increases and reaches the breakover voltage, the diac here it smoothly turns on. The switching is very sharp and quick. So once it starts conducting, the current flows in either direction depending on the applied voltage. So it will continue to conduct until the current drops below a certain level, which we call that as a holding current. After that, this turns off again. So this on and off behavior makes it useful for the switching applications. So next we'll discuss about the VA characteristics of the diac. So the graph of the voltage versus the current is symmetrical in both the direction as you can see. So initially when the voltage is low, only a very small current flows. As the voltage increases and reaches the breakover voltage, the current it starts to rise. The voltage across the diac decreases even though the current increases. And this behavior is known as a negative resistance. And because of these characteristics, Diac is very suitable for triggering and switching in the AC circuits. Advantages and application. Now let us discuss how the Diac is being used. It is mainly used in light dimmer circuits to control the brightness smoothly. It also used in the fan speed control circuits. Another important application is triggering the triac in the AC control systems. Additionally, it is used in heater control and motor speed control applications also. The advantage of the diac is include simple construction, reliable operation, and the ability to reduce the noise in the circuit. It also ensures a smooth and symmetrical operation in the AC system. So let us quickly summarize here. So what we have learned today. So Diac is a two-terminal bidirectional device that conducts only after reaching the breakover voltage. So it operates symmetrically in both the direction and is mainly used for the triggering TRIAC in AC power systems. In switching behavior makes it very useful for practical application like dimmer circuits and speed controllers. So these are the references and a quick quiz to test the understanding. So a diac is primarily used for triggering the triac circuits, and diac conducts the current when the applied voltage exceeds the breakover voltage. So thank you. So we come to the end of the today's lecture. Thank you for your attention. I hope you have understood the concept of diac. Keep following the concepts and we'll continue in the next video. Thank you.